Now that we have settled onto a logic, let's get into the detail of the implementation. Now, I set the overall complexities to n, but you do see that sometimes you have to place the cows outside the grid. And then you can actually pre-calculate the maximum amount of outside space that you would need. Because, for example, let's say the width of the bottom is 1,000 cells, then if all of those 1,000 cells are populated, we could create 998 comfy cows at the bottom level. So because the one on the sides cannot ever be comfortable. So what will happen in the worst case is that we're gonna place 998 cows and then or markers, and then those markers will then need 996 and so on. And we know that we'll need 500, up to 500 additional rows on all four directions. And what that means is you just increase the size of your actual grid to 2,000, and then start your initial coordinate. So you want to convert coordinate 0, 0 to like 500, 500. Okay, so with that said, here's what you would also want to do to make it easier and make it a little bit more efficient. So here's my TP table, or the actual grid, and 0, I will represent 0 with the number 2. I represent X with number 1, and an empty cell will be a 0. So this grid is initially 0 filled. I would also create n count, where for each cell, I'll keep track of the number of neighbors or neighboring cows that each cell has. So that way you don't have to keep recalculating or recounting. Okay, so placing the first cell here, what I'll do is to increase the neighboring count of all of the neighboring cells. And then I just keep going. So with this, I'll be increasing these two counts to 2, and this to 1, and this to 1. Let's keep going. So with that one, 1, 1, 1, 1. And with this one, it's going to be 2, 1, 1, and then finally a 3. Right? So with that 3, what we need to do is to start a flood fill. So as you populate a row, as you place a cow here or here, in this case, we place the cow there actually. When you place a cow, you have a chance to have an uncomfortable cow there and at all of its neighboring cells. So you want to start flood fill in those 5 places, making sure that nobody is comfortable. And then in order to keep everybody from being comfortable, you might have to place something. And as a result of the placement, you would also have a chance to create other comfortable cows. So you can do that using recursion. Okay, so in this case, we have an uncomfortable cow, which means we're gonna place an X here, and with that placement, what you do is to increase, because the markers also contribute to the neighbor count. So this will be that, but this will be a 4, right? So at that point, you do not have any comfortable cows. Each time you bring in an X, you simply increase the X count by 1. Okay, so that's what will happen. Now, as we bring in a cow, replacing an X with an O, you can simply decrease the count and decrease the count back to 0, and nothing is supposed to happen to the n count because, well, that marker was already accounted for. Okay, I'm gonna place the cow here this time, again increasing the neighboring counts, and then I'm gonna place a cow here. And then with that, it'll be 2, 2, 1, and 3. So with that 3, we have to bring in a marker, increasing the count back to 1. And this marker then increases its neighboring counts as well, making that a 4. Okay, and then let me just go ahead and finish simulating this, the sample input. So with that, we have 3, 2, 1, 1, and all of these intermediate values are something you can actually print and verify. So that creates a 3. So that 3 means we now have something that is comfortable. So we're gonna have to bring in another x, increasing the count to 2, and that x also increases the neighboring cells. This will be a 4. Right? And then finally, the most interesting one is this one over here. So with that, we have 3, 2, 1, 1, and that 3 means we have a comfy cow. So with that, we'll bring in something, a marker cow, and that marker cow changes this to 4, but in turn changes this to 3, and then we keep propagating using recursion. And with that 3, we need to bring in another marker cow, which in turn increases the n count of the neighboring cells, at which point we don't have anything comfortable, and because of these 2 additional x's, we increase the x count to 4.